So we can use the distributive property to help us evaluate expressions or simplify expressions, particularly expressions with a variable component, because if our expression in example 4 part A here had a number plus 4 inside parentheses, we could just follow the order of operations. We could evaluate what's inside the parentheses, then we would multiply that by 5 and add that to -8. But because we have that variable component, the only way that we can look at simplifying this is by applying the distributive property to rewrite this as -8 plus 5 times p plus 5 times 4, which will give us -8 plus 5p plus 20. And then whether or not we need to think about that commutative property of addition, we can reorder those addition steps to rewrite this as -8 plus 20 plus 5p. So now we can combine those like terms to get 12 plus 5p. Obviously a much simpler expression than what we started off with. In part B, we can do the same thing. We'll distribute 5 through the expression x minus 2, which will give us 5 times x minus 5 times 2 minus 5, or 5x minus 10 minus 5, which will simplify to 5x minus 15. In part C, now we have 2 distributive steps to take care of. So first we'll take 4 and distribute that through the first set of parentheses. Then we'll take -9 and distribute that through the second set of parentheses. This will give us 4 times n plus 4 times 9 and we're going to write this as plus -9. So I'm going to look at it as distributing that -9 through the set of parentheses minus -9 times 7 minus -9 cancels out. I guess I do that in green. Minus -9 cancels out to make that positive, so we'll end up with 4n plus 36 minus 9n plus 63. Then we could look at reordering terms, or if we can do that more intuitively, we know that 4 and minus 9n would combine together to give us minus 5n, and 63 and 36 would add together to give us 99. In part D, we again have 2 distributive steps, but what's a little bit different is now these variable terms each have a coefficient. So when we distribute through, we'll have to multiply both 2 and 5 by that corresponding coefficient. Meaning we're going to take 2 times -2p plus 2 times 8 plus 5 times -7p plus 5 times 1. Now, before we look at combining like terms, we'll take care of these multiplication steps. 2 times -2 will give us -4p, plus 2 times 8 will be 16. 5 times -7 will give us minus 35p, plus 5. And then combining like terms will give us -39p, plus 21. In part E, we have some expressions in parentheses, but no constant out in front. But if we imagine putting in some placeholder values of 1, this is the same thing as taking 1 times that quantity x plus 4 minus 1 times that quantity x minus 7. So we can always think about multiplying by 1 since that doesn't change a value. What we're doing in the first set of parentheses is distributing a 1 through, so really nothing changes. Where we had x plus 4, we can just write that again, but drop those parentheses. Then we're subtracting 1 times 7, or I'm sorry, 1 times x. Sorry, I'm going to go back a step. We're going to think of this second expression as being plus -1 times x minus 7. That's going to help us keep track of those changes in sign better as we go. So this is going to become plus -1 times x minus -1 times 7. So we'll get x plus 4 minus x. The two negatives will cancel each other out to give us plus 7. And then our two x terms will cancel out. 1x minus 1x will be 0x. And then 7 plus 4 will be 11. So we get 0x plus 11, or just 11.